Good evening, everybody. I am so pleased to welcome you here once again for a Zoom lecture in the framework of Layer 2.0, the competition we're just doing now at the Living House Research Institution, dealing with how does the second layer of the city look like. And after doing more than 25 years of conservation in Tel Aviv and topping up buildings, this is the time to look at what we're doing and also try to think what's going to happen in the future. So for this specific reason, I have invited two super interesting lecturers and colleagues of mine. One is Lilach Harel. She's a teacher at the Bezalel Academy, where she's doing an architectural studio, and also she has been part of the competition from the start. And she's also part of Lilach Drog Architects. They're doing a lot of amazing projects in Israel. And the second lecture we have is Nirit Amir. She's from ESD. It's a company dealing with retrofitting, with environmental thinking and design, but she's gonna, I'm sure, tell you all about it. So today we're really dealing with what does it mean to do retrofitting, or what does it mean to think ecologically also when we're topping up buildings. We'll have two short lectures, and after them we'll have time for Q&As. So please write down everything that is not clear or you would like to ask the two of our speakers, and we'll see you after that. We'll start with Lilach. So please, Lilach, if you want to share your screen, please do.
Yes. Hi everyone. Sharon, thank you for the introduction. I have been practicing architecture and in the field of conservation and sustainable design in the last decade as a partner in Goa Garel Architects, and also lately in the Academy of Bezalel. And I had the chance in my career to work in all kinds of scales and sectors, from policy making, from municipalities, from government offices, real estate developers and private owners. And I think these combinations of academy and the practice gives a unique platform to think and deal with these challenges that we are going to talk about, and to understand the opportunities that lies in the combination with the conservation and sustainable design in the built environment. When Sharon asked me to do this, to speak about conservation in the era of sustainable revolution, I realized that I don't want to focus about how energy upgrades have been done, although it's of course a big part of this issue, but to focus more about how can we develop a strategy that combine both of them. Usually when we approach this issue, we use it as two parallel strategies, and I want to suggest a way that we can combine it and take it as part of our planning. So, but before I dive in to how we divide it and how can we try and look at it, I want to define the base of this discourse. And I think the phrase, the greenest building is the existing one, is actually one of the researchers that was a benchmark in our practice. This research was led by the Preservation Green Lab. It was calculated the LCA for historical building, and it compared it to new building. And after this research, they did also a research about the quality of historical urban fabric, older, smaller, better, and another researcher. And this research showed us that it takes between 10 to 80 years for a new building with 30% more efficiency than the average to overcome the energy of construction. So we know now that one of our biggest mission as an architect is to understand how we reuse and adopt historical urban fabrics and historical buildings, and how can we combine these two philosophies and making a sustainable solution and environment. So with the growing awareness and the challenge we face with climate change and the growing population, we need to understand how we involve, how we change our practice. What is the aesthetics of this practice? How can we change the economics model? What part of community we have? And many more questions that I think rises when we start to deal with this subject. Mostly we need to ask the right question in a way, and to understand that we're in the beginning of a journey, and a lot of the answer we don't have yet. So in the last 200 years, we have witnessed great change in the way we live. Work, consumed, starting with industrial revolution, through the capitalistic revolution and growing population rate that now have never been witnessed before. We have come to the time, I would say in a way, of the era of ecological revolution. We are trying to find ways to connect the built environment to the natural one. Nowadays, we start to understand the complexity of the system and how we are part of it. We start to think about how rewilding a city, like you can see here in example, the green roof of the municipality of Tel Aviv. We are thinking about blue and green infrastructure, dealing with biophilia, embracing biomimicry, and other methodologies that will enable us to be part of the ecosystem. To achieve the goal of reducing the carbon footprint, in a way we need to rethink the way we live, but also the way we build. And I think this lecture is trying to start and explain how we can do it. Through the history, sites, though historical sites, we can see a lot of qualities. The challenges we are facing today are very different. The way we live is different. And the practice of conservation is about understanding how these historical layers, how we can incorporate it into new scheme and sustainable design. We, of course, should take a big part of this. Sorry. So what is sustainable conservation? If I try to define it, I think the difference between conservation and sustainable design, I think if we compare Venice to New York, we can start to visualize it. And International Symposium that organized by ICAMOS and the Getty Institution in 2001 coined the phrase managing change, which in a way started to talk about the combination of these two approaches, which marked the shift in our discourse and open new doors, maybe even a Pandora box, to shift and the focus from not only on heritage value, but also on the importance on how we're adopting and adding new layers. This shift to intervention-based practice also incorporates the necessity to redefine the scope of our work. Here you can see a project in Taiwan that combines landscape and design, abandoned structures, shift the way we practice the indoor, the way we perceive the indoor and the outdoor boundaries. What if we can take and relate to different structure or topologies to different infrastructure? What are the other boundaries we should re-examine? How can we redefine it? Stating the obvious, of course, new technology should also take part of redefining those boundaries. A great example is what you can see here, the low lane in New York. This experimental project breaks the boundaries by using technologies and bring light to the underground. It was closed, unfortunately, but it was about creating underground space, green underground space park in an abandoned train station in New York. So to define an integrated approach to sustainable design and conservation, I want to suggest three main strategies. Sustainable conservation based on two questions we need to ask first. How can we use existing building, and what is the relationship between the intervention and the historical structure? So these three strategies that embodies the relationship between this, the value of and the authenticity of historical site and the degree of intervention, and how we incorporate sustainable design. Retrofit, I will divide it into three: retrofit, rethink, and reshape. Each one is on a scale that explains the relationship between the intervention and the existing structure. The first one, the retrofit, which is the most common strategy in the practice of sustainable conservation, would be retrofit. If we look at the strategy if we look at it as a balancing act, retrofit is emphasizes the value of historical site and how the framework of the site, the craftsman, material, how it all can be part of the upgrade of the performance, keeping it and its authenticity. Retrofit mainly refers to energy and water upgrades, and it's very common in monuments, of course, and also in a lot of existing building upgrades. And today, I think it's the most common one, and maybe generally organized way. It's the only way that we really focus when we talk about this connection between sustainable design and conservation. I think the most known example for this, and the pioneer one, was a project of the Empire State Building, the building that opened to the public in 1931, and in 2010 started an overall retrofit, mainly focused on energy efficient and upgrade with an aim to reduce 35% of energy use, and it was aimed to have an ROI of 3 years. Different strategies were implemented, from windows upgrade, LED light implementation, sensor control, a lot of different interventions. This improvement achieved great reduction on the building maintenance cost, and it became a case study for windows upgrade methodologies that can be implemented in existing buildings. But if we look at retrofit, we need to remember that we shouldn't only focus on energy efficiency and upgrades in buildings, although it's, of course, a very important part. But sustainable design is also about community and economy. And Aga Khan, in their project El Darb El Ahmar in Cairo, I think it's a great example, and we can see it as a retrofit project that uses different tools based on values of the historical site. They came up with an holistic approach program presenting from education, micro banking, for local businesses, home upgrades, and different other tools, for which the aim was to use the building and the infrastructure for the rehabilitation of the conservation of the historical fabric. And they did it by aligning from the community needs and the economical models and the historical site, harnessing the opportunities and qualities. This management base, which is, I think, the key factor for the success of this project, uses the historical site and its community as the main asset. So if we started at the retrofit as the beginning, and you see here also craftsman work that was part of the plan to empower local communities and create new jobs, a big part of the rehabilitation, and then a holistic approach. The second one would be rethinking. So if retrofit focus on the value of heritage, rethinking it's somewhere in the middle. Rethinking it's a strategy that is based on the combination. It's between sustainable approach and conservation. And it's about the tension between the old and the new. And many times, this tension brings to life and emphasize the historical building and urban structure. This tension we can find from changing building usage, implanting different scheme of natural light or ventilation, and of course, changing the surrounding. The first example I will give is Curitiba in Brazil. But before that, I think rethinking is about respecting the old and still celebrating the new. When we deal with historical urban fabric, we need to have an integrated approach. Curitiba is one of these cases that during the 70s, which happened in a lot of places around the world, but during the 70s, it was facing a major development project that mainly was about implementing car-based infrastructure. And this project threatened the historical fabric of the city. And Chaim Lerner, which later became the mayor, and back then was still a graduate at architecture, was leading a movement against the existing policy. So the strategy was led by Lerner was based mainly about rethinking the way the city works, how we use the infrastructure, how we're thinking about and combining all the elements together, how we can make the city a place for everyone, how we can rethink the infrastructure, how can we keep the historical assets still by doing so. And his plan included engaging from public recycling program to transforming the center to pedestrians, creating a bus station that he developed and that later he made very known for it, to make the public transportation more efficient. And today, Curitiba is considered to be one of the most sustainable cities in the world. The next example is about the building scale. So rethinking, it's the ability to, if we look in a project that we can examine separately, that we can see the difference between the addition and the historical site, but still give it a new meaning as a whole. In this project, we can identify the historical site, but we can also see the new meaning. This project, the Cole Drop Yard in London, is designed by the Retrofit studio. I think it's one of the best projects to demonstrate this approach. It was originally built as a pair of elongated Victorian building that received call from North England for distribution around London. And later on, it was used for light industry, warehouses, nightclubs, and until it was abandoned in the 90s. The main challenge that architects had here was how to convert this industrial building to a commercial area and redefining the public scheme and creating a circulation of a public square. And they did it by two design languages that we can see that used to emphasize the intervention approach. We will later see another project of the same studio that uses the Reshape approach, which I think it's very interesting to compare to understand it. The last strategy, so if we were in a retrofit, which is, let's say, the authenticity and the historical site is the main and we think it's somewhere in the middle. Reshape is the last one, and I would say I would like to suggest it in the Reshape Strategy, and in a way I will compare it to the aesthetics of ruins. Reshaping is about creating new meaning, not by erasing, but fusing new ideas into the historical site. This strategy, you will need to be more active to read and to separate between the two layers of the intervention and the historical site. If we look at these three strategies as a scale or balance between things, between conservation and intervention, so Reshape would be in the intervention side. So by 2050, the world's population will be 9.7 billion, most of which will live in cities. And the pressure on the built environment, as we already feel now in the practice, forces us to reimagine and redefine the future of our cities, while realizing how we can achieve biodiversity, air quality, efficient clean transportation, healthy building, and more, Or if we put it in other words, how can we make sustainable cities? So facing a shift in our built environment, we need to think outside the box. And I think this chance will also affect the strategies of the intervention, also in historical fabric and historical sites. So redefining our environment invites us also in a way to redefine our mythologies. The garden, this example you see here, when you can see the historical site, you see it used for some part of time as a petrol station. You see on the right, the stage right before they started the project, which part of it was collapsed during the year. But so this example, the reservoir was a vital source of water and for the growing population in the 19th century, and it stopped supplying water in 1899. Then it used as a garage and a petrol station, and later on was listed as an heritage site. And what I think unique about this project that it restored its underground spaces, but still revealing big part of the structure that collapsed, and using this collapsion as part of the main strategy. And they convert it into gardens and public use. So the project restored much of the reservoir originally. They use it for all kind of public uses, of the structure. But they also, in a way, reimagined the space in a new way. They used the original bricks and timber and fixture and salvage, and was part of the site infused into the contemporary sustainable elements in the project. The last project, which I want to show, which also was designed by Etherwick Studio, and I think it's a very unique example, is the Mocha. The Mocha was built inside an old grain silo in Cape Town that in the waterfront during the 20s. And the architect team, they carved a huge section out of the building tubular interior to create a complex of network of 80 galleries spaces. We can see here how they carved it and how they use it also to bring natural light into the building. When we look at this project, the new interpretation of the facade and the interior, we can understand in a way the metamorphosis of this project, combining the old and the new into something different. And I think this is the main thing about reshaping in a way. We can still understand it's about this fusion between the old and the new and giving it a new meaning. This lecture, as I realized by now, is in a way a call to rethinking and embracing the potential of conservation and sustainability. 80%, we need to understand, of our building today will still operate by 2050, which means that most of our work will be dealing with existing urban fabric and structures. So what if we rethink Tel Aviv through this prism? I think this competition is all about that in a way. How can we use this new perspective and ideas? How can we rethink or reshape the city of Tel Aviv? So good luck, everyone. I hope this short presentation intrigued you to explore it a little bit further. Thank you.
Thank you, Ilach, for all those really interesting projects that you showed us from all over the world. I'm sure it's inspiring for those people who want to attend our competition. And now, please, Nirit, I want to also say that Nirit and I had the honor to get introduced when she did an outstanding work researching the Liebling House itself. So the building that the Liebling House, the White Center, is at, was researched by ESD with Nirit Amit. And I don't know if you're going to talk about it, but I was really amazed to see I'm going
to talk about it.
Good, so I leave it to you. Thank you, Nirit.
Thank you. Hi, everybody, good evening. My name is Nirit Amir. I'm an architect, but I work in a consulting company that offers sustainability consulting services to projects of all kinds in Israel and abroad. In my line of work, I mostly deal with energy aspects of buildings, and I usually try to look for ways to plan and build energy efficient, sustainable buildings. I wanted to talk about how existing buildings built before the arrival of climate control mechanical systems can be an inspiration to us, and what we can learn from analyzing the way they interact with their surroundings. And I will share my presentation. Okay. So I'm gonna speak about retrofit. Of the three options that Lilach showed us, I chose the first one. And, but I am going to show you in detail what we did in the Liebling House and how we analyzed its original plans to try to understand how it interacts with the climate and what we can learn about it. So as I see retrofit, okay. Retrofit is a renovation approach where the main concern is about making the asset to renovate useful again. It's designed to extend the effectiveness, the effective life of the existing building by adapting it to the changing surroundings and to the needs of the modern tenant. But what changes are we talking about? What changes in the world around us that may cause a building to become useless or obsolete? So first of all, in the last decades, we have seen the urban tissue change radically. Its density, its physical conditions, its physical characteristics are changed in many ways. We see bigger windows, we see a lot of glass, we see much less opaque walls. This may change the building's performance under specific climate conditions. It changes the way it exchanges energy with the outside, and it changes the amount of energy needed to achieve comfort in its internal spaces. Glass facades also reflect sun and sunlight in a different way. They add reflection, and they may cause glare and heat stress. high-rise, which we see growing in Tel Aviv very quickly, may affect the local wind microclimate within an area that is twice their height. So we will probably send and avert the influence of seafront new constructions in Tel Aviv. And maybe we can already perceive the large areas that are affected with this activity. Recreational leisure. People used to pass leisure time interacting with each other and mostly on the open air. Nowadays, we mostly spend our time in closed climate controlled piazzas, and we interact much less. So maybe this is why the importance of shade in public spaces that used to be very clear to planners, maybe nowadays it's not that clear. We can see around the cities these little deserts that we make and no vegetation and nothing that can mitigate the heat absorbed by the pavements and the walls. All these influence also the performance of the buildings around it. Maybe the biggest challenge in the city is mobility. The volume of traffic has been growing relentlessly for decades, and we are willing to take some drastic steps to pay and pay a lot of money just to have a place to deposit our car at the end of the day. As you can see in the picture, many listed buildings in Tel Aviv are undergoing this kind of operation of excavating parkings underneath them. And the most, maybe the biggest change that we see in the way we plan buildings is the way we treat climate control issues. Many of the planners that worked in Tel Aviv in the early decades of the 20th century came from European countries, and they were not used to the high temperature and the strong radiation they found here. So to guarantee thermal comfort, they use mostly shades and to keep out the summer heat, and natural breeze to exhaust excessive heat. Heating system of any kind were rarely installed in the buildings because heating needs in Israel were limited then, and they are still today. But then, in the 80s, air conditioning systems came by, and very quickly they became widely used, not only in commercial buildings in Israel, but only in residentials. Over the years, it looks like we kind of forgot to consider climate as a planning resource or a planning condition. As the world stands on this climate action crossroad, maybe we need to reconsider this. We know we can no longer rely on the endless supply of fossil fuels to fulfill our energy needs. So we need to learn how to employ all renewable resources we can. Israelis will probably continue to use ACs, but if we plan correctly, we can reduce consumption significantly. When we analyze existing buildings, we sometimes have the opportunity to get a glimpse into an architectural expression of planning with climate. Some of these expressions are approximation. Some of them may seem even casual, and many of them are no longer even relevant because of all the changes we mentioned before. But I think that climate and the surrounding of the building could be an inspiration, an interesting inspiration, and maybe a start point. Moreover, we now have things that the architects in the early decades of the 20th century did not have. We have very accurate weather data, we have calculation methods, and we have simulation tools. So let's say we want to plan additional stories on top of an existing building. Let's say we would like our building to be high-performing, efficient building. Why don't we start by trying to understand how the original building works with its surroundings? To understand it, we would need to get to know the climate and the microclimate of the building. And we will need to understand the past microclimate and the present microclimate and try to adjust the solutions to what we learn. So just in few words, for those who don't know climate in Tel Aviv or maybe forgot, generally speaking, we can say that weather in Tel Aviv is greatly affected by the Mediterranean Sea. It moderates temperature in the city throughout the year. And although temperature in Tel Aviv are getting less and less moderate, it's still, we still have our Mediterranean to take care of it. Mediterranean is also responsible for high level of humidity and heat stress, and it also the origin of cool evening breeze and some 3 to 5 strong winter storms. So to really understand the choices made by certain architects, we need to know what were the conditions that prevailed at the time of the planning. To be able to evaluate and reuse a climate control technique, we need to analyze the changes in the building environmental condition and the changes in the way we use our buildings. In 2016, we were asked by the Liebling House to analyze the climate control strategies used by architect Dov Karmi in this 1935 residential building situated in the heart of the White City, a building that we know as Liebling House. I would like to share with you some of the things that we found and show why we believe that climate control may have suggested some of the architectural expressions that characterized this building and many others in the White City. Oh, sorry. So looking at the building plot, the thing that stands, this is a Liebling House building plot as we modeled it in a CFD simulation program. And we tried to understand how come this building plot is somewhat complex and how come it is positioned in this precise way. So this initial planning decision is the basis to design passive cooling and heating techniques. You can see how the Max Liebling main facade faces west with a somewhat like 20-degree rotation to south. This was the envelope surface facing west is as big as it can get. So what do we have on our west side? We have evening breeze from the sea, okay? So this allows all dwelling units to receive a very good amount of sea breeze and enjoy natural ventilation during all day. The west front remained open until the early 60s when the 6 stories residential building, the 31 Edelson Street, was built. This affected the direct airflow on Liebling House. And according to our calculation, the new building caused a diminution of average wind speed by 2 or 3 meters per second. That's a lot of speed. This specific building forms create pressure difference between the 2 main fronts, between the west and the east front. We have high air pressure zone on the western front, while eastern facade forms a small, some kind of an internal courtyard to ensure pressure differential between fronts east and west. And this way facilitate cross ventilation within the living spaces. If we look at the northern corner of the building, we can see it's rounded. We know many international style buildings in Tel Aviv that have rounded corners, but we believe that in this case, the rounded corner helped moderate the turbulent wind that may create nuisance exactly in the point where we have the convergence between high pressure and low pressure. You can see on the upper east side of the building. So maybe this architectural expression was in a region, maybe, a method to achieve better conditions in the street. So if we go drill down into the building, we can see the position of the openings on the west and east side. The position and size of the opening influence the manner and speed in which wind flows within the building. Most of the living rooms in mass living house, there are at least 2 openings on external walls. This increased the airflow through the room and ameliorates its distribution. Openings between rooms facing different fronts increase the flow between rooms, and all external openings of the structure are fully openable. The arrangements of the internal spaces is not casual. All living spaces face west to ensure good natural ventilation. Service spaces face east and used to exhaust air from kitchen and from other service spaces. Openings with integrated fixed wooden slates on the eastern front ensure continuous airflow across the building from west to east. So the position, we can see opening between rooms and corridors that are usually windowless. At first, we thought it was they were fixed and were not openable, but then we realized it was they were used for increasing ulteriorly the wind speed within the living spaces. Another widely used architectural elements are the recessed balconies that we can see on 29th Edenson Street on the south side. The balconies are formed as a void concrete box and leaving a relatively small passage to air. We've found documentation to support our assumptions that this element was designed to increase the wind pressure around the windows and the amount of air penetrating in the living spaces, using a well-known physical phenomenon called Bernoulli effect that causes air to flow more rapidly when passing through a bottleneck. You can see how air is literally being sucked into the balcony in the simulation you see on your left. You can see how air rushes into the balcony space without a very apparent reason to do that. So we think it was, although these balconies, we can see them in a lot of buildings in Tel Aviv, maybe it was originally a passive cooling technique. On the other hand, as far as passive heating concerned, solar direct radiation penetrate buildings through glazed opening, where it is absorbed by the building massive components and then converted into energy when temperature drops. In Tel Aviv hot climate, The correct way to use solar energy is to maximize exposure in winter and minimize it during the rest of the year by designing adequate shading devices. The southern facade of the Liebling house is exposed to direct sun, but is small and the windows are recessed. It seems that European Israeli architects that operated in Israel in the early 30s were more concerned about protecting buildings from summer heat than letting in radiation during the winter for passive heating. Another free resource that these buildings tend to use is natural illumination. Beyond its health-related aspect, natural illumination benefits in terms of energy can be significant. Energy consumption for lighting can be very wasteful compared to utilizing free natural resource. So we can see wide glazed area, high glazing area ratio in all rooms. We can see fixed windows opened in the upper parts of the walls to contribute to amount and quality of natural lighting penetrating the living spaces by unifying its distribution in the room. Internal windows between rooms and corridors carry natural light into windowless corridors. And the use of glazing in common spaces, like staircases, is found in many international style buildings in Tel Aviv. This window supplies light and ventilation into the stairways of each building at each building levels and has become a typical element of this architectural period. Shading, as you can see in the upper picture, is the most effective tool to control sunlight and to avoid overheating of internal spaces. In many existing buildings in Tel Aviv, we can find a great variety of shades that allow different degrees of flexibility through partial or full opening. And the last issue I would like to talk about is envelope composition. The external walls, as we found them in the Liebling house, are built of double layer of silica bricks. Silica bricks were one of the first construction material in the city of Tel Aviv because sand was extracted from the nearby beaches and dunes and bricks were produced locally. It is definitely a zero-kilometer construction material. Since the 30s of the last century, bricks were used to build many buildings in Tel Aviv. Silicate bricks are in fact kind of a sandstone, but as it contains quartz, but it's manufactured through an industrial process. The bricks has very high resistance to weather condition. The great mass of the wall inhibits temperature changes inside the building. Silicate bricks can regulate their humidity content, thus avoiding appearance of molds and fungus. Another quality of silicate bricks is their high acoustic performance. Silicate bricks walls do not reach the minimum thermal performance required for insulation, but they get close to it. And they present qualities that newer construction materials do not have. So we really should consider conserving as much silicate brick walls as we can. So these are the main characteristics that we found in the Liebling house when we analyzed it. I do think that analyzing, watching, and trying to learn from the way architects used to plan with climate can help us understand how it works and if it works, when it works, and like choose the elements that can still be useful and still present many advantages and may make us reach a very high performing building even before we choose the system, the mechanical system that will make it function. So just before you start planning, try to understand the way the original building know to work. That's it. Thank you.
Thank you, Nirit. This was also very interesting. I learned a lot. Thank you so much. About the silicate bricks, it's always so surprising that they can perform so well. Can you just elaborate a little bit more on that? I'm very curious.
What would you like to know?
Well, what makes them perform well? Is it their sort of, I don't know, I mean, the aggregates inside that I mean, you know, I had this experience in Germany where everybody started cladding their building in order to prevent, you know, the heat to come out. And there was a lot of emphasis after a while that some of those walls were greenwashed, meaning that they were, you know, maybe isolated too much. I mean, of course, in Germany, it's a total different climate than here. But I always wonder if the walls need to breathe in a way.
Yes, it is a very important issue, especially in Israel and in especially in coastal cities like Tel Aviv, because humidity is very high, as you know. And if we don't let the air in and out regularly, building tends to get molds and fungus. And I visit a lot of new buildings that have serious problems of molds. And when I get there and people ask me, what should I do? I keep telling them, open the windows. Because using ACs and keeping our interiors always controlled makes it difficult to building materials to regulate the amount of humidity they have inside. And silicates in particular are known to accumulate and let out humidity with a certain facility. So they can help equilibrating the amount of humidity that we have in our ambience where we live. And I know of very little cases where silicate bricks develop molds. So it's, I think maybe it sounds a bit hippie way of thinking, but I think that because it originates locally, that it can deal with local conditions better than other materials.
Well, I know, I think I like this approach of looking at vernacular sort of building methodologies and also materials, of course. I think that's a very interesting way to see it. But I still wonder, I mean, do the exterior plasters and the interior paint affect the amount of evaporation a brick can have?
Yes, of course. If we use even partially polymeric substance, the wall will breathe less than it would if it would be without any polymer content. And we need to investigate better this area. I know that there are some research in this area in Italy where they still use silicate bricks, and it's kind of maybe it's disappearing as a construction material because it's no longer sustainable producing it. But we do need to cherish what we have and keep whatever we can before we think about changing the walls. Also about humidity, we now install better windows. So the windows we install now do not let much air infiltrate into the house. This also influences the quantity of humidity that we have in the air inside. So it's a combination. But I do think we need to think about it, especially in places like Tel Aviv, where humidity can reach 19%. It's fundamental.
Interesting. So are there any other questions maybe from Lilach or from any other participants in those two lectures? If there are, maybe one can raise their hand. Yes, I don't see anything, but I'm maybe not so equipped here with my phone.
יש לנו שאלה בצ'אט.
נכון.
כן, מה השאלה?
נירית, תוכלי בבקשה להסביר שוב את הסכמה של חצי אוויר בנושא המרפסות?
כן.
In English, please. So the question is about the scheme of the balconies at the Liebling house. If you can explain it again.
Oh, the balconies, right? So not this. I guess you meant this. So I will try to show you in a better way. So these balconies, actually, we can find them here. Can you see my mouse moving? Can you?
Yes.
Okay. So these are the balconies we're talking about. As you can see, air is penetrating, coming from west. But not necessarily it will penetrate deeper into the house. So what architects used to do is to straighten and leaving almost too small passage for the air to come in and approach the windows. So at the beginning, we looked at this passage for the air and we thought, why should you shut it down? You should open it. And then we modeled this, this part of the building in the CFD simulation program. And we saw, because we found documentation that talks about this practice that was used. And we saw that actually the air tends to be sucked into the balcony because it's a kind of a bottleneck. In the whole front, we have these little cuts that make the air penetrate into the balcony and approach the window. So this is a classic Bernoulli effect. We know that when a fluid is being pushed through a bottleneck, it will flow in a higher speed. So this is the effect that was used. It was until I saw this documentation that talks about this technique, I would have never thought that this could work. Then we put it into the model, into the CFD simulation, and we actually saw it worked. I hope it was clear.
Yes, thank you, Nirita. There is one or two more questions from the audience for Lilach. actually, and then we'll have to finish because we had 1 hour already. But Jimmy is asking if there is a space for thinking about climatic solutions when you do conservation, and also if there is place for new materials together with the old ones. So this is a question for Lilach. Lilach is not here. Yes.
זה נתקל? Sorry, my computer was stuck and I couldn't hear your question. So.
Okay, I don't know if I phrased it correctly because it was done. It was asked in Hebrew, but Jimmy was asking if when you do retrofitting or when you do, conservation, if there is a place for thinking environmental friendly, for environmental friendly solutions on one hand, and if there is a space to integrate new materials with the old ones.
I think the question is, of course, it's really a question about what is the intervention and about the surrounding. I think the most important understanding, it's not that we are not going to add additions or that our surrounding will never change. It's exactly the opposite. We should use everything that Nirit said about the materials and understand how the building and the surrounding are working together. And I think maybe this is the main failure today, that we don't understand this connection, that there is a tree in the street or the next building, how it affects our surrounding, and how two materials, that one is based lime and the other one is based cement, can or cannot work together. So of course, I think there is a place for new interventions and also for new technologies in new buildings, because I think basically in some cases, not all of them, I think of course we need to remember that if we can use the DNA of the historical site, we should do it. It's an asset that we should use as part of our planning. But I think many times when we have big additions to building, and I think in Tel Aviv, in many cases, this is the case, it changes the scheme of all the way the building is working, how the ventilation, the air, if we add in Israel, you add a lot of time like a safe area, which is mainly concrete based, and so how does it change? It's like the facade that used to be part of the ventilation scheme now it's changed, and we need to understand how we need to correct it and add it to the new. I think it's one to understand that it's part of our responsibility, also not only to understand the historical, but also to really integrate the two things. We can separate it, and of course we should use new technologies and sometimes new materials.
Thank you, Lilach, for the answer, and thank you, Nirit, also for your answer. I think that was very interesting, and I'm sure that our viewers had a lot of information that was new for them. So I hope that we will do conservation as well as new buildings with, of course, all of those subjects we've talked about, considering first and foremost the well-being of the inhabitants within the space and their relation to the climatic conditions. So thank you for that. I want to invite everybody for next week's lecture is with Shmuel Groag from Groag Harel Architects, Lilach's partner. He's going to talk about the vernacular architecture of Jaffa. And Ruti Liberty Shalev from the Technion is going to talk about the Geddes plan. And of course, all those subjects are also connected with the environmental one. So thank you again, Nirit and Lilach, and I hope to see you again soon.
Thank you all.
Thank you.
Have a good night.
Thank you.